Hello fam, in this video we are going to go through the free response problems for pages 1 through 10 in your review packet. I don't have a packet with me, but I don't know if it's the green or the blue one, sorry. But we're going to be doing pages 1 through 10. So how I'm going to format this is, I'm going to tell you where you can find this at in your notebook. I would highly recommend that you try the problem and then look at the solutions. So I'm going to give you the hint. You should pause the video. Then when you've done it, you can come back and, well, unpause it and check your solutions. I absolutely would not rely on me to get you through this review. So, and I'm going to make myself big so that I can really drive that point home. So, if all you do is copy down what I'm writing, if all you do is put me on mute and just pause the video and write down what I'm doing, that is in no way whatsoever going to prepare you for this exam. It's going to get you the points, the 100 points towards your grade, but that's it. And that's meaningless. If you don't get the credit in the end, if you don't really do the work, then the grade means nothing. And that's kind of a concept I think that means more to you as you get older, like older than you guys are. But I would just know that if you rely on me to do all of these problems, then you will not be successful on your exam. You really should do what I'm saying. Rely on your notes, try the problem, check your answer. It takes a lot more time, but you'll get so much more out of it in the end. So that's my spiel. The first problem is on categorical versus quantitative data. So this was actually one of the very first things that we did in class. I have it labeled as lesson 1. And this is labeled as page 1 in my notebook. This goes through and tells you the difference between the two, and then actually gives you problems toward the end that are exactly like the problem that they're asking you on page 1. So, dang it, just rip my page out. So you're going to want to refer to that page as you work through this. I should have said pause. Here are the solutions. For part A, you could have just said the individuals are the vehicles. You didn't have to be quite as specific as I was, but I would recommend that you be as specific as possible. Okay, question 2. It gives you the results to a survey and then wants to know how the distribution of opinions differ between men and women. Give appropriate graphical and numerical evidence. So this is based off of conditional distributions. This is categorical data, and you've seen this on pages, well, I have labeled 112 and 113. So they say independence or association. You are going to make a conditional distribution and then a segmented bar graph or a side-by-side bar graph. There is another one on page 113. So numerical evidence would be the percents inside the table. Graphical evidence would be your segmented bar chart. So if I uncover my solutions, they think that what is going to influence your response is gender. So they're looking at whether or not there's a difference in opinion between the genders. So you can see from my work that I have here and from my segmented bar graph that men are more likely to agree or strongly agree with the statement. So if you go through and add the agree and strongly agree, that's 67% of men, but only 48% of women. So when you describe that there's an association, you want to say 3 things. You want to say there is an association between blank and blank. Be specific. So in this case, there is an association between gender and opinion. Then you want to refer to your graph. the segmented bar graph above shows that men are more likely to agree than women. So I have said there's an association and was specific about between what. I'm referring to my bar graph. I'm making a more or less likely statement. And then I'm going to give specific values. 67% of males agree or strongly agree it's right to use animals for medical testing if it might save human lives, but only 48% of women agree or strongly agree. And that's it. That's all you have to say. There is an association. Refer to your graph. Say they're more or less likely. Give specific values. You have, I think, a couple more of these problems in the next pages. So if you weren't able to do this one on your own, really go through my work, see if you can fill in the gaps for the things that you're missing. And then as you move forward, genuinely try the problems after this that have to do with conditional distributions. And speaking of, this is the problem on page 3. The problem on page 3 is another one like the problem I just talked about on page 2. So they want you to make a two-way table of temperature by outcome. So instead of having these two things here, what they want instead is hatched, not hatched. So they want you to change this and make one of them the number of eggs that hatched, the other one the number that did not hatch, and then that column will add to 27. Same for the neutral, same for the hot. Then they want you to answer part B, which is very similar to the question that we just answered on page 2. So I would maybe make a graph or compare percents and then try to frame your answer like I did in the last one. So pause and try it. Okay, so here's part A. Here's my two-way table. Notice that the totals in my column match the total number of eggs. So of the 27 eggs that were in cold temperature water, 16 hatched, 11 did not. 56 neutral water, my column there adds up to 56. 104 in the hot water, my column adds up to 104. Hatched, yes or no? Okay, percent hatched between the three different temperatures. And notice each denominator is different because this is a conditional distribution. We want to know the percent of eggs in the cold water that hatched, not just the percent overall that hatched and were in cold water. We want to know the percent of eggs that were in cold water. So denominator is different in each. I have that neutral and hot have the best hatch rate and cold has the lowest hatch rate. Now, even though they're not like hugely different, there is a difference between them. So I'm saying the data do support the beliefs that the eggs would be less likely to hatch in cold water. The conditional distribution shows that the lowest percent of eggs hatched was in the cold temp group. Only 59% of eggs hatched in the cold group compared to 68% in the neutral group and 72% in the hot group. Okay, page 4. They give you a question about left-handed, right-handed, ambidextrous. So we want to make an appropriate graph, and then we want to estimate the number of high school students that is left-handed for a Canadian high school. So first thing on this problem is notice that your data is categorical. There are only two types of graphs that you can use when your data is categorical. So you want to go to the categorical data tab. So it's bright yellow. And you want to remind yourself of the two types of graphs that you can make for categorical data. Then part B is actually a lot easier than you think that it is. So the best hint that I can give you on part B is just don't overthink it. It's actually a very simple answer. So pause, make your graph, come back and check. I decided to make a pie chart just to remind myself how to do that. I have my key here. The colors match over here. I could have done a bar graph. I feel very comfortable with bar graphs though, so I wanted to do one that I don't do quite as often. I could have gone through and labeled each section if I wanted to. So this is a graph of the data. Part B, based on the pie chart, which is our sample, so you could also say based off of our sample, I would expect 6% of the Canadian high school students to be left-handed. So easy. The part B, after everything we've done in this year, I think we're all inclined to think that that part's a little bit more complicated, but honestly, we know if we take a random sample from the population, that sample will represent the population. So it should be that if 6% of our sample is left-handed, then 6% of our population is left-handed. So either way, what I have written in red here, and if you see any other solutions that are written in red, they're in red because I do all the problems and then I check my answers. So anything I add in red is something that I didn't have that I thought maybe I should add that in for you guys. So based on the pie chart, based on the bar graph, or based on our sample. Page 5 is another conditional distribution. But in this one, they are just asking you to specifically use the table to find some percents. So what percent of the people in this study were elite soccer players? So they just want to know overall how many were elite. So I just said this is another conditional distribution. It's not necessarily a conditional distribution. You literally are just trying to see if you can figure out what they're really asking you and what number you put in the denominator. So for this one, I don't really have a lot of great hints. Basically, all I can tell you is that you're going to want to make fractions. Okay, percent of elite. There were 71 elite players out of the total, so about 8%. Percent that had arthritis was about 5%. Notice that both of those were based off of the table total, which means they're marginal. These are marginal percents. Then it says what percent of elite soccer players had arthritis. So how you say this in stats is with these symbols. What this means is what percent had arthritis given that we know they're elite soccer players. So your bottom number is going to match what comes as the given. So how many had arthritis given we know that they are elite players? About 14%. Then the next one is opposite of this. What percent are elite given that we know they have arthritis? So 43 people had arthritis. 10 were elite. So about 23% of our people who had arthritis were elite soccer players. So this is giving you an opportunity to practice whether or not you can find the specific percentages requested and knowing, is it a marginal? Do I use the table total or is it a conditional? And I'll use a row or a column instead. Okay, page 6. This is the same table, but it is the conditional distribution. So when we talked about conditional distributions, what we talked about was when you make your conditional distribution, you want to make your denominator the variable that you think influences the other variable. So here, we think that how much soccer they play is going to explain whether or not they had arthritis. So that's what this arrow is meaning, that we think that soccer playing will explain whether or not they have arthritis. It wouldn't necessarily work the other way around. Like, I don't necessarily think that arthritis would impact whether or not you play soccer, because arthritis typically isn't something you get till later on in life. And if you're an elite player, then you've been playing for quite some time. So we suspect that more serious soccer players have more arthritis later in life. Do the data confirm this suspicion? So you are going to want to make a segmented bar graph or two bar graphs to compare against each other. You can see my conditional distribution already done. Notice my explanatory variable is what I base my fractions off of. So for my elite players, I'm basing it off of the number of elite, the number of non-elite, the number of who did not play. Make your graph and then state something along the lines of there is or is not an association, more or less likely, refer to your graph and use specific numbers. You really should try this one without me. Okay, here is what I decided to do for my graph. In this case, I decided to try a different graph than the segmented bar graph because I already did that in the previous problem. So this time I just compared the bars next to each other. So we can see that for the non-elite and the did not play, those percentages are approximately the same. But for the elite players, there is a difference. I have labeled and scaled my axes. Remember how super important that is. In fact, if I go back to my segmented bar graph, I did not label this axis, and I really need to. So I should have labeled this percent or relative frequency. This is 0, 1, 2, 3, 4, 5. This is 50. This is 100. Always scale and label. So back to page 6, I've scaled and labeled, I've given a key, and then I'm going to use that in formulating my response. Yes, the data confirm that more serious soccer players, elite players, are more likely to have arthritis than less serious players, the non-elite. Elite soccer players are also more likely to have arthritis. Elite soccer players are also more likely to have arthritis than those who did not play soccer at all. The graph and percentages in the table above show that the rate of arthritis among non-elite and non-players is about the same, 4%, but the arthritis rate for the elite players is 10% higher at 14%. So you don't have to word yours exactly like mine, but you want to make sure that you're saying that the data confirm their suspicion. You want to refer to how or what you use to determine that, meaning your table or your bar graph. And you want to try to give specific numbers with a more or less likely statement. So it's a lot to add in. Hopefully you're feeling good about it at this point. As long as you have those things, you will have full credit. It doesn't have to be like mine. Okay, next up, the dot plot. Are there any outliers? Oh, so this is socks. You can't even see my page, my bad. This is page 7. They want you to describe the distribution. So you want to do shape, center, spread, outliers, and hint. Actually use the 1.5 times IQR to determine if there are outliers. So here's mine. The distribution of travel times in minutes is skewed right with a median of 15. I am being specific. Make sure you are as well, and that you're using context, sorry. So you shouldn't just say the distribution is skewed right. You really want to add in the distribution of travel time. You can just pull whatever they have on that x-axis. The distribution of travel time in minutes is skewed right with a median of 15 minutes. So I did shape and center right there. Travel times vary from 0 to 90 minutes. That's range. But if your data is skewed, you should not use range. You should use IQR. So to be on the safe side, I always include both. Now, remember, you want to do your best to use the word vary. Do not say travel times range from 0 to 90. Range is a very specific value. So you don't want to say travel times range. Just say travel times vary. My IQR was 10 minutes. There are 4 high outliers. So remember, if the outliers are on the right-hand side, you call them high outliers. If they're on the left-hand side, you call them low outliers. Finding median and quartile 1, quartile 3, you would want to go back to our pages on outliers. Sorry, I didn't do a great job of telling you where to go on this. So not box plots, but we had a specific page where we looked at, okay, so outliers. On the outliers lesson, if you go to the back of that page, so I have it labeled as 128, it specifically goes through and shows you how to find the quartiles. So if you need a little bit of help with that, you'll want to go to the page that's headed as outliers, and on the back, it shows you how to do quartiles. Okay, we're getting there for this video. We're on page 8. So we want to compare the distributions. On this, remember that you always want to do shape, center, spread, outliers, just like on the previous problem. You have to use comparing words. So you want to say the shape of this one is right skewed, but the shape of this one is left skewed. The median for this is higher than the medians for these two. The range is greater for this one than for this one. So use comparing language, compare everything, shape, center, spread, outliers. We have a specific page for this. It is in quantitative data, and there's a really good example on comparing distributions on the back of your box plots page. So here's box plots. On the back of that page, it walks you through comparing distributions. I'm sorry that I have to hold the papers up like that. It's just really hard because of this document viewer. It gets in the way. If you have your quiz 6, I have it in with my notes. The solutions to quiz 6 will also give you quite a bit of guidance. So pause, write it out, and then come back to see my solution. Okay, for mine, I just used bullet points and made sure to include shape, center, spread. So all 4 are approximately symmetric with no outliers. Comparing the medians, we can see that both kind of cars get better or greater highway mileage than city mileage. For both city and the highway, 2-seaters typically get gas mileages lower than gas mileages for mini compacts for the city, but it's only slightly lower. So how I know that is I'm looking at the medians. When we say that comparing medians, we can see that they both get greater highway mileage. So if you compare just these two against each other, the highway mileage, the median is higher than for the city mileage. And if you compare only the mini compacts, it's the same. Highway is greater than city. So that's the first part. For both the city and the highway, two-seaters typically get gas mileages lower than gas mileage for the mini compacts. But for the city, it's only slightly lower. Okay, so what they're saying is for both city and highway, if we look at these medians and compare them to these medians, so for highway, the mini gets better gas mileage, and for the city, the mini gets better gas mileage, but they're very close. Like these two are very close together. These two, it's a little bit more obvious that the mini gets better gas mileage. So I compared the mini to the two-seater, mini to the two-seater. And then the last one, you just want to look at the length of the box plots. The length of the box plots tell you how they vary. So the mini compact for the city has the least variation. It has the smallest range. So gas mileage varies more for the two-seaters than for the mini compacts. So their length of box plot is longer than both of these. So like this one is longer than this two-seater city has a bigger range than both of the mini compacts, and this two-seater highway has a bigger range than both of the mini compacts. So I'm saying gas mileage varies more for the two-seaters than for the mini compacts, because for both the two-seaters, the range is larger than the mini compacts. For both the city and highway, two-seaters have a greater range in IQR than the mini compacts. So shape, center, spread, outliers. Because there were so many box plots, I did not pull any specific values. If this were one of your free response problems on the exam, you would want to go back and fill in values if you had time, because this is quite a lengthy problem. You may not have wanted to spend time finding out exactly what is range, what is median, so on. Okay, two more. Explain how you could end up getting a median of -31 and a mean of 111%. So I have a lot of solution here because I wanted to make it as clear as I possibly could how I was getting my answer. But I'm hoping you guys know, even if you can't formulate your response, that this is related to a distribution being right skewed. So they're telling you that your mean is greater than your median, and that only happens when your data is right skewed. So explain how this could happen. Well, the most basic answer is it happens when your distribution is right skewed. Here is all of the things that I thought would be important to write down in order to show fully that I understood this. -31% means that the stock lost 31% of its value. So if the initial price was 100, the current price is 69 because you lost 31% of 100, which is $31. So then I kind of drew a picture of that just for myself. So that means a -100% would mean that I lost all of the money that I put in. 0% would mean there was no change. It's still worth 100. If my net change was 100%, that means I doubled my money. Instead of $100, it's $200. And then you can see to the right that I just kept going. Now, this is not required at all to earn full credit, but I felt like before I could even attempt to answer, I needed to make sure that I understood what this problem was saying. So how would we end up with a mean greater than a median? So this is all you really needed. This could happen because the median is not resistant to outliers. Sorry, the median is resistant to outliers and the mean is not. Since the mean is greater than the median, the data is skewed right, and there are likely high outliers because the mean is so much bigger than the median. The high outliers would pull the mean farther right than the median of -31. So I'm just trying my best to say I know that the mean will be greater than the median when the distribution is right skewed. And the difference between these two, -31 and +111, is so large that I bet you there are outliers. Not only is it right skewed, but there are outliers out here that are really pulling your mean up. I don't know what the shape, like, I wouldn't know where to put the peak. So I didn't draw it on because, like, would I put the peak at 50%? Would I put the peak at 100%? I didn't feel good about deciding where the peak would go, so I didn't put it on. Maybe this means that it's like that. But we have to keep in mind that for this mean to be so much bigger than the median, you really do have some outliers here that are causing problems. Okay, last one in this video, page 10. Okay, so this is standard normal. So really the better one to look at for this is our overview, our Unit 2 overview. So what they're asking you to do is take a normal distribution, convert it to a z-score, and then find the area related to the z-score. In your book, this is in the standard normal section. So it's a purple tab. So it's this tab. And you need to go quite a ways in before you can see like the real world problems. So I have page 308, 309. Okay, so try it and then come back and see my solution. Part A. They want us to, sorry. Is this a... Oh, they don't give us the mean and standard deviation. Sorry about that. So they tell us that researchers found that the average student loan balance is $23,300, and then they reported that about 1/4 of the borrowers owe more than... Okay, so that's actually... Okay, so I'm just going to walk you through this one on my paper. We know that the mean is 23,300. And we're given an X value of 28,000, but we're told that 25% of borrowers owe more than this. So here's what they're giving us on the normal curve. My median, or my mean, is 23,300. They tell me that where this flag is at, there's 25% of the data above it, which means that 75% of the data is to the left. Well, why do I care about the area to the left? Because my purple table only gives me areas to the left. So I can't focus on this part, I have to look at this part. So that means that I have to go inside the Z table, so inside, and find the number inside that is closest to 0.7500. that matches a z-score of 0.67. So now if I work backwards and I go to 0.67, you can see that that number is very close to 0.7500. So now I can use this formula to solve for sigma. So I plug in everything that I know and I solve for sigma. To solve for sigma, you just switch these two things. Sigma is about 7,015. So one thing that the key had that I did not write down was that the standard deviation is about 7,015. Like they actually wrote out a phrase to match their answer. Using the standard deviation, you just calculated how many borrowers owe more than 50,000. Okay, well, we have to find our z-score for 54,000. So 54,000, subtract our mean, divided by our standard deviation, gives us a z that's not even on our table. Our z-table only goes up to 3.48, which means, 3.49, which means that the proportion of borrowers who owe more than 4,000 is about 0%. So according to the statistics we have, nobody owes more than 54,000. So then C says the report states that 10% of borrowers owe more than 54,000. What does this fact indicate about the shape of the distribution of student loan balances? Well, the distribution of student loan balances then is not approximately normal. Up at the top it says, assuming that the distribution of student loan balances is approximately normal. Well, if C is true, if in fact 10% of borrowers owe more than 54,000, well, now we know that the distribution of student loan balances is not approximately normal. If the distribution were approximately normal, none of the balances would be more than 54,000 based on Part B. In Part B, what we have is that if this distribution is normal, no one will owe more than 54,000. So if 10% of people really do owe more than 54,000, then the distribution is not normal. Then lastly, the report states that the median is 12,800. Does this support our conclusion in Part D? Yes. A median as low as 12,800, which is almost half, indicates that the distribution of student loan balances is skewed right, because the mean greater than the median always means skewed right. This problem is super important for you to understand. So if you are struggling with this problem, make sure that you come and see me so that I can talk to you more in depth about Part A or Part B, because I would imagine that's what you would be struggling with. So any part of this that does not make sense, please make sure that you come and ask questions. And for that matter, on any of these pages 1 through 10, if you need a little bit more guidance, if you have questions, just ask me. This is another reason why I was saying in the video on our Canvas page that it is super important that you try to get these problems done by Friday so that you actually have enough time to come in and get all of the questions that you have answered from these review problems. So any additional support you need on this problem, just let me know, and I'll be happy to walk you through it. Okay, that's it for pages 1 through 10. I will make another video for 11 through 20.